Hello everyone, you are on Vectali, and today we are going to solve few moderate questions from rotational dynamics. Rotational questions hit different. They look calm, but one small force can flip the whole system. Let's break down today's problems with clean angular logic. Question number 1. A uniform rigid lamina of mass m and area s can rotate about a fixed vertical axis that is in the plane of a lamina. While the lamina is rotating, excess pressure P created by forces of air resistance at a point on the lamina is given by the equation P is nothing but K into V, where K is the positive constant and V is the speed of the point under consideration. If the lamina is given an angular velocity omega naught, how many revolutions will it make before coming to complete stop? So this lamina is of random shape, some random shape. So you can't name it as dx and take some vertical elements or horizontal elements because that becomes complex. So I'm just taking a small element of area ds. So first, what are they asking? How many revolutions will it make before it completely stops? Correct. And it's given an initial angular velocity of omega naught. So we need the angular retardation created by this air resistance force. Correct. So let's first think about this. All is the air resistance force acting on these two sides, on both sides of the axis, produce the same directional torque or different directional opposite torques. Let's verify it first. If this is the center and this is the top view of the whole system, and this is the lamina, if this is rotating in this direction, the air force will, the drag will be acting in this direction, right? So on overall, these two forces combine to produce torque in the same direction. So we can directly sum it up. Okay. So let's take the small element ds, which is at a distance r from the axis. Okay. So the torque produced by this is d tau, which is force into perpendicular distance. What is the force? Pressure into area. So kv into area is nothing but ds into r. So v is nothing but, as it is in proper rotational motion, I will write v as omega r. Okay. So omega is the instantaneous angular velocity. So k is nothing but omega r square ds. So tau is nothing but, if we integrate on both sides, k omega r square ds, and which is k omega integral r square ds. We have seen this pattern somewhere else, right? R square ds. We know this thing, right? Moment of inertia is nothing but r square dm. So anyway, we have to convert this ds into dm. How are we going to convert it? With the help of this one keyword, uniform. So as it is uniform, let's assume its surface mass density as sigma. So what we get is, if we multiply and divide by sigma in this equation, k omega by sigma integral r square sigma ds. What does sigma ds signify? It's mass, right? So integral r square dm. So what does this represent? It's just moment of inertia. So k omega by sigma into moment of inertia. And we know this particular relation. Tau is nothing but I alpha. So we got alpha. Alpha is nothing but k omega by sigma. So we got the angular retardation. So what next? We know the angular retardation. Initial angular velocity omega naught. So omega naught. As it is a retardation, I can put as negative sign. So it's omega naught. And we have to find theta. And the final omega is 0. Omega final is 0. So omega final square minus omega naught square is nothing but 2 alpha theta. So final is 0, and this is omega naught square is nothing but 2 into k omega by sigma into theta. So what we want is theta is nothing but omega naught square sigma by 2k omega. So this is the required theta. But what are they asking? They are asking the number of revolutions. So we have to divide it by 2 pi. So number of revolutions n is nothing but omega naught square sigma by 4 pi k omega. So this is the number of revolutions which the lamina undergo before it stopped. Question number 2. Two uniform triangular plates ABC and ABD of the same thickness, height, and made of the same material are shown in the figure. If moment of inertia is of these plates about the axis PQR, IC and ID, which of the following statements is true? Okay, they are just comparing between IC and ID. This is an kind of analytical question. This is an easy question of that type. Why have I included this question is because this includes the derivation of moment of inertia of a triangle. You can practice more questions on derivation of moment of inertia. That's an easy thing, but I have been just doing this one for triangle. Okay, if you see these two triangles, they have the same height, same base length, so their areas are same, half into base into height are same, and the thickness are same and made up of same material, so they have equal mass. This is the first consideration analysis that we are doing with respect to the triangle ACB and ADB. Now, moment of inertia is nothing but integral of dm into r square, as seen in the previous question. So I'm just considering a random triangle, okay, in which the breadth is b, height is h, okay, and I'm taking horizontal components, each of thickness dy and length x, okay. Now, if you see this triangle and the bigger triangle are similar, right? Because these angles they share as well as this angles they share by AAA property, which you might have studied in your lower classes. So as these two are similar, the ratio of lengths is also similar, right? So x by b, I'm writing it here, or b by h. Okay, b by h is nothing but x by this distance, which is h minus y. So if I do this, I just created a relation between x and y, which is necessary because for right I, moment of inertia, first let me expand dm. Dm is nothing but let's the density of the material be rho into thickness into area, right? So the area is x dy of this particular part, small component, x dy. And we have mass is the total area into density into thickness. That's it. Now, if you see, x varies throughout, correct? X is not a constant. So x should be related to y. That is why I am doing this relation of similarity. If I apply similarity of triangles, I get BH equal to x by h minus y. So x in terms of y. So if I substitute it here, I will get the moment of inertia. So if I substitute there, I is nothing but this value. So rho t into integral of 0 to h bh by bh into h minus y into y square dy. Upon integrating it completely, what I get is mh square by 6. So let's compare. This is the moment of inertia of any triangle of height h, where h is measured from the axis of rotation. So here the axis of rotation is this. Okay. Now, in case of triangle ABC and ABD, they have same mass, okay, and same height. So of course, mh square is same for both of these. So the IC is must be equal to ID. That is the conclusion over here. In case of different kind of shapes, you try just integrating them by this method, or you just see it. If a shape is like this, some random shape of this and this of equal mass, and the axis is over here. If suppose the axis is here, which has more moment of inertia? Of course this, because moment of inertia is the mass occupied at this any particular position into the perpendicular distance square. So here, if they have equal masses, also this particular thing has r square term greater than this thing. So this has more moment of inertia than this. So these are some intuitive things which you must know in order to attempt the analytical questions. Question number 3. A disk placed on a frictionless horizontal plank is rotating with a constant angular velocity omega about its central vertical axis. Okay. Now the plank is made to move with a constant acceleration a on the straight path. If you assume the initial location of the center of the disk as origin, direction of motion of the plank in negative y-axis of the coordinate system attached with the plank, which of the following equations represent the trajectory of instantaneous center of rotation? Okay. So they are speaking about the instantaneous center of rotation. Now let's first analyze why the concept of instantaneous center of rotation comes here. Now we will move to the Planck frame. Why? Because the coordinate system is attached to the Planck and the Planck is moving downward, that is in negative y direction. So if we fix with respect to the coordinate system, we will fix with respect to the Planck. So I'm just going with the Planck frame. With Planck frame, what happens is as the Planck is moving down with respect to Planck frame, this particular disk will move up with acceleration a. Correct. So this moves with the velocity of at in positive y direction. Okay, and the coordinates of this center is same. The x coordinate doesn't change. 0 comma half at square. Okay. Now this omega naught will not get affected because it's placed on a frictionless horizontal plane. If they have friction, this guy will try to move with this plane. Also, this omega will reduce. Okay, there will be no relative motion. The friction will try to reduce the relative motion. Now, let's assume that the C be the instantaneous center. Now, I'm stating that the instantaneous center C has y coordinate as half at square. Why? There's a question arises. Why? Okay, let me do it. If, for example, if there is a body, a square body, which is root over here, and there are few points. Okay, let's mark these points. This body is going with an velocity in this direction v. Okay, or each and every particle in this body is going into velocity v in this direction. So the center for this lies in the same axis as the center of mass. Okay, or let's assume this body to be thin. Okay, this be thin. It lies in this particular frame at infinite distance. Okay, because this is perfectly vertical, so it lies in the center, lies in the infinite distance. Okay, now but in this case, let's assume first omega naught is in this direction, so it's in the k cap, positive k cap. Omega vector is omega k cap. Now what happens is, if this whole system without this velocity, from this frame, if I see, its center of rotation is here, but this center of rotation with respect to the Planck is moving somewhere in this direction. So this coordinate gets shifted to either this side or the other side, but they lie in the same horizontal line. Why? Because this rotation with respect to this center should be maintained, as well as this vertical velocity should also be maintained. So it should shift only in the horizontal direction. Just pause this video and intuitively verify yourself. If you have doubts, then comment. Okay. Now, in order to compensate this particular vertical acceleration or vertical velocity here, as we are speaking about the instantaneous center, we are just shifting it in the horizontal direction, either this direction or this direction. Both are okay. So now the y coordinate should be the same as they lie in the same horizontal axis, which is y is half at square. What about the x coordinate? We don't know about it, right? So let it be x comma half at square is the coordinates of C. Now, with respect to this center, this moves with the velocity, some velocity v, correct, in this direction. This velocity is supposed to be 80, correct, because both should be horizontal always, 80. What about the horizontal velocity? Let's see, this 80 should be, with respect to this center, this boy should be in rest. So this 80 is nothing but omega into this distance is x, because this is lying directly above the origin. So this is lying some distance x, so which is negative x supposed to be. So minus omega into x. Okay, this omega into x, sorry, omega naught into x. So what I get is x is nothing but at by omega naught, minus at by omega naught. If I square on both sides, what I get is x square is nothing but a square t square by omega naught square. Okay. Now what I get as, now t is the thing which we have assumed, that is the time. So we have to eliminate these two things. So let's divide. Y by x square is nothing but half. Now 1a goes into denominator a and omega naught square goes top. So I get y is nothing but x square omega naught square by 2a, which is this particular thing, and x is negative. So option A is correct. If you move to option B, what it says is the omega naught is in opposite to this. So the omega vector is minus omega into k cap. Okay, in that condition, what happens? We are just changing the sign of this. So if we are changing the sign of this, x becomes positive. So becomes positive, but the final answer remains the same because anyway we are squaring it. So we get B2. So option A, B, both are the correct answers for this particular question. Just pause this video and verify the logic behind this thing. Why am I shifting this center from here? If you have any doubts in that, do comment. Question number 4. A boy riding a bicycle at a constant speed describes a circular path. Wheels of the bicycle are identical and axles are a distance L apart. If the front wheel rotates eta times faster than the rear wheel, find the radius of the circular track traced by both the wheels. Neglect tilting of the bicycle from the vertical and slippage of the wheels. So this is a much realistic question. Very interesting question from Pathfinder. What happens is they are saying this is the particulars from side view. This is the front wheel of radius r and by a rear wheel which is of radius r. As they are saying it rotates eta times faster, its angular velocity is eta omega and this is omega. Okay, now let's come to this part later. Now if you see, if you're moving in a circular track in a cycle, what will you do to remain in the path? So you have the handle which can control the direction of the front wheel. So that is the concept. Either you can tilt it to the left or you can vertically tilt the whole cycle to the left so that it moves to the left, correct? So there are two methods or two ways to turn left. If you are moving with a high speed, just try this. If you're moving in a cycle with some particular speed, some high speed, either you can turn it completely or you can just tilt your cycle with respect to the vertical axis so that it will move in the correct direction. So what they are telling is they are neglect the tilting of the bicycle from the vertical. So the second method is not possible. They are only speaking about the first method. With the only the first method we can achieve this condition. We can go in this particular path. So for this condition, the cycle should go like this. This is the front wheel which we are going to tilt it. It goes with velocity v1. This is v2 because there's no slippage. And if these two are in the same straight line, they can't be without slippage because both have different angular velocities. So considering pure rolling, the lowermost point or the center has velocity eta omega r and the speed of the rear wheel at the center has omega r. Okay, and it's an uniform circular motion, right? About this particular center, even this wheel as well as this wheel goes in uniform circular motion, correct? So this length distance between them is L and I am assuming this is R, so automatically this is perpendicular, right? Anyway, this is the tangent. So this radius vector and tangent is perpendicular, so this is of course perpendicular. By Pythagoras theorem I get under root r square plus L square. So about the center C, each wheel undergoes an uniform circular motion. So this V1 is nothing but, let's assume with respect to this, it's going with an constant angular velocity omega. There is capital omega. I'm just writing it as W over here. Okay. So if I write in this way, V1 is omega, capital omega into under root R square plus L square, and V2 is omega into R. Let's divide it, V1 by V2. So if we write V1 by V2, what I get is under root r square plus L square whole divided by R. Okay. Then we have this V1 and V2. If we divide it, we get eta. Correct. So this is nothing but our eta. So let's square on both sides. So if we square on both sides and multiply that r square over there with r square eta square. So L square is nothing but r square into eta square minus 1. So L square by eta square minus 1 is r square. And r is positive. So we can say r is L by under root eta square minus 1. So this is the value of r. And the another radius, this is the radius of the rear wheel. What about the front wheel? Under root r square plus L square. So just write it. If you write plus L square plus this thing goes multiplied with L square again. So eta square L square minus L square whole divided by eta square minus 1 whole under root is what we want. So we get plus eta L whole divided by under root eta square minus 1. So this is the radius of the front wheel. Okay. So the radius of the circular tracks traced by both the wheels are L by under root eta square minus 1 and eta L by under root eta square minus 1. So this is a very interesting question. They may ask these kind of questions in JEE Advanced because anyway we are going to bridge the relation between real life practical examples and the theory that we are going to learn in our 11th, 12th or engineering something. Okay, thank you for watching this video. Do comment your doubts. We are here to help you. Stay tuned on Vectally.